Alright, so in contrast to a couple of the recent videos, this one should be actually pretty short. We're going to just introduce electrical current, and then we'll have another video or two to give more detail. So electrical current is really simple. It's basically, the concept is simple, the working with it is not so simple, but basically it's the flow of electrical charges is what happens in current. That's its definition. So where does that happen? Lots of different places. Everywhere in a modern society there's electric current all over the place. So I just put a couple of pictures to give you that idea. This is a typical sort of a circuit diagram, although none of those are not really standard symbols. But that gives you an idea. You've got a source of electricity. It pumps current around a circuit. There's usually a switch, and then maybe it turns on a light bulb. Here you've got danger, keep off tracks, electric current. So you've got that whole like third rail thing going on, where one of the rails of a train might be electrified. Here you've got just basically this might correspond to this right here. You've got a switch and a light bulb, and then there's a source of current over here. So current is basically flowing electrical charges. Usually they flow through a conductive circuit, such as perhaps this, which is a diagram, or this right here, which is the actual wires that might turn on an actual light bulb. So current is flowing charges. Alright, so that leads us to a very important distinction. Static electricity involves charges that are stationary, that are not moving, and current, electric current, charges that are moving. Alright, so current can flow in a couple of different ways. Current might flow through conductors, usually metals, throughout a circuit. So there might be a circuit of wires with some kind of device hooked in there, like a lamp or maybe a toaster oven or microwave or something like that. That's going to be powered by the electrical current, and it's just going to flow through those wires into the device and then back again into the wall. So usually electrical current flows through a circuit like that, but it can also flow like in liquids, for example. So in this case, what's moving, what charges are moving? And the answer would be electrons. All right, so electrons move in wires, metallic wires. It's the electrons that do the moving. If you have electrical current flowing through a solution of liquid, like this, a liquid thing there, then that it's not electrons specifically that carry the charge in this case, but it would be ions. So you might have, for example, some sodium plus ions, and then you might also have some chlorine minus ions, and perhaps those are floating around in there. Although this says it's a copper chloride solution in this particular picture. But if it was sodium chloride, then it would be sodium plus and Cl minus. Probably copper chloride, it would be, my guess would be it would be probably Cu2 plus and some Cl minuses floating around in there. But, you know, whatever. That's more a chemistry thing, dealing with solutions that have ions carrying charges. We don't deal with that too much in physics, but that is one way that charge can flow, that you can have current, is if the ions in a solution move around. That will also produce current. But typically in this class we're going to be talking about electrons moving through conductive wires. Okay, so in any case, bottom line, in order for current to flow, there must be charged particles that can move. Now, metals have free electrons, and then electrolytes have ions. So an electrolyte is basically a salty solution in a liquid. We call it an electrolyte if there are ions dissolved in a liquid. All right, so that's that. Those are the two ways that you can have current flow, the two main ways. Now, in terms of mathematics, current is defined as charge over time. So your equation for that is going to be this guy. Q represents charge, I represents current, and T is time. So yes, that's weird. I, current, well, I don't know, honestly. That's how they defined it a long time ago, and it stuck. Same thing with Q. Why Q, I don't really know, but it's stuck, so now we use it. Obviously, current and charge both start with C, so you can't have C for both of them, so we have C for neither of them. In any case, that's your standard symbols for this mathematical relationship. So current is basically defined as the amount of charge passing a given point in a circuit in a given period of time. So if you know the total amount of charge that flows past that point and you know how long it took, then charge divided by time gives you the amount of current that's flowing. So that's pretty cool. The units for current are called amps or amperes, and that's abbreviated as an A. So 1 amp would be 1 coulomb of charge in 1 second. So anyway, that's basically it for this video. We've introduced current and we've given you an idea of what it is and how to define it. We've got the equation, so we can use that later. And that's all there is to it for now. We'll get into a lot more with this later, but hopefully that was helpful. Thanks for watching, and we'll catch you next time.